Ready. So good morning.
Wait. I'm sharing the
I'm Mohsin
presentation.
Mujawar. Good morning. I'm Mohsin Mujawar. Today I'm going to present my project report on productivity improvement on chassis A line by cycle time reduction. The content if, you are seeing in the slide. The abstract of the project. This project has been carried out and successfully implemented in Mahindra Vehicles Manufacturers Limited. Basically, on chassis A line, the capacity is getting limited to 40 JPD. JPD is jobs per day, and due to that, bottleneck station due to the three bottleneck stations. This project is related to increasing productivity by elimination of bottleneck stations. When this problem arises, I took a responsibility to improve the capacity from 40 to 64. 64 is the requirement in line with the market demand. Post our analysis, we found that these are three bottleneck stations on the chassis A line are the hurdles for the increasing capacity. And productivity of chassis A line improvement resulted into the following key benefits. One is that 20 numbers manpower straight away we have reduced. Overall line efficiency is improved from 87 to 91%, and output per product is improved from 1.18 trucks to 1.28 trucks per person. Introduction. Project is implemented in Mahindra Vehicles. Project is implemented in Mahindra Vehicles Manufacturers Limited. This project is implemented in Mahindra Vehicles Manufacturers Limited. The project is carried out to increase the capacity of productivity of chassis airline by capacity enhancement, and the chassis airline productivity is getting impacted due to the capacity increase, and due to the higher numbers, two shift operations were required, and these two shift operations are resulting into the manpower increase in manpower cost and reduction in overall efficiency. And the three stations on chassis line found bottleneck. Productivity improvement target we have taken that line. The target is line capacity increase from 40 to 64 JPD. To execute this project, we have referred various literatures, such as one book and 12 journals and many case studies. If you see on the screen, overall efficiency is the key factor in the improvement productivity. So I have referred the Japan Institute of Plant Maintenance 4th edition. Many case studies from TPM experts, Mr. K. Sonone. This case study is presented during the JIPM plant level TPM assessment and other case studies as well. Basically, what is the problem and problem in hand? The problem in hand is that suddenly in the month of Feb onwards, the market demand has increased from 900 to 1,595 trucks. And truck manufacturing operation is working in single shift to cater the market demand, which is 900. But to cater the 1,500 plus market demand, the capacity which is we are having with the 40 JPD is not possible. So to do that, we have to run two shifts with the 40 JPD one shift, 24 JPD one shift. And by running this two shift, there are major losses was happening on the manpower side, electricity side, conversion cost side, and truck manufacturing losses. If you see the truck manufacturing structure, we have total 7 lines. In that, trim, engine, and chassis B line was equipped with the 64 JPD. Other final line, chassis A line, and axle lines are not equipped. They are their capacities are final line is capacity is 52. Axle and chassis A line capacity is limited to 40 JPD. Other 3 lines projects were taken by other teams. I have taken a project to improve the capacity and improving the productivity of chassis A line. Details of the problem. If you see in the, as I explained, if you see in the chart, these are the lines, and the cycle time of a particular line is shown over here. With this cycle time, we can meet only 40 JPD on axle and chassis A line. So considering that chassis A line we have taken for the project, methodology we have used to execute or to complete this project is DMAC. Define the purpose of this step is to clearly pronounce the business problem. Our business problem is that we have to cater the market demand. We have defined what is the our purpose is, and measure the purpose of this step is to measure specification of the problem. The data we have collected, the capacity, what is the capacity, and all everything is collected. Now we clearly measure what we are and what we want to be. Then analyze. We analyze the problem, improve whatever the recommendations we have given. We have implemented it, and control whatever the recommendations implemented. The control mechanism we have established to ensure the improvements are in a execution phase. For doing this, many data collection we have done. That in as you say in industrial engineering practice, there are primary data and secondary data. In primary data, we have collected the production. What are the production target, output reports, how many work content are there, line balancing sheets, everything we have collected. And while collecting that, with the help of industrial engineering, we have analyzed the non-value adding activity, how many activities are there. So this data is the primary data we have collected. As the secondary data, with that data has been captured by some other person, other agencies, for other purpose. That data we have used for our purposes, such as workstation capacities, breakdown MIS and analysis reports, and overall line efficiency report, which is getting generated by the TPM cell. So in primary data, in primary data, you see in the graph, these are the sources from where we have taken this data. And with this data, we did a data analysis. If you see in the chart, from September 18 onwards, the September to August, the average working days are from varying from 26, 27 to 25. And in the market demand for our trucks is getting increased from March 19, which is 1,500 plus trucks in the month. If you see over here, to cater this, we have to move it to 64 JPD. So while doing that, to meet this 64 JPD, we have two options. One is that 40 JPD in one ship, 24 JPD in other ship, or 64 JPD. As you see, 64 JPD is a hurdle for chassis A line. If you see here, clear analysis that two shift, the major manpower manpower increases, the 20 manpower we are getting increased due to the two shift running. Particularly, if you see the chassis A line station wise capacity with respect to the takt time, there are 10 working stations on chassis A line. Out of 10, 7 stations are lying in the capacity zone. They can able to produce the 64 JPD with their takt time. But if you see the 3 stations, axle dropping station, U-bolt tightening station, and chassis inversion, these are the 3 stations where the takt time is higher than 10 per minute, 10 minutes. So these are the bottleneck station for our capacity enhancement project. So we have analyzed these 3 stations thoroughly. We have analyzed the operations, how many operations are getting done, process times, manpower. Here, if you see prima facie, you can see that you can increase the manpower, add one manpower on axle dropping, U-bolt and this thing, and you can do it. No, this is not possible, because this axle dropping, every station is having 3 manpower already working. So there is a manpower crowd is again an issue. There are some few processes which are taking this standard time. So the challenge is that we have to we want the challenges and problem on the table was there. We have to reduce the process times. We have to reduce the takt time by distribution of work. So these are the problems we have taken for the our project. So if you see debottlenecking of these 3 stations we have started. The recommendations to debottleneck these 3 stations came into the picture. We have a leaf spring fitment station. Previously, it is getting dropped by a simple crane, and this has limited the workspace, and due to this, the time is getting increased. So we have implemented jeep crane over here. It has benefited us and stage owner to complete the activity in workspace is getting increased. The other recommendation, due to the truck pitch, our truck is 12 meter in feet. 12 meter in length. So after a single truck, the another truck is getting dropped at the 3 meter location. So the 3 meter conveyor travel is. Am I audible, Pawan?
Yeah, yeah. Now I'm out. Now your voice is audible.
Yeah. So we have reduced that pitch and the time is reduced. Then if you see on the inversion station, basically there is a while doing inversion, the belt is getting rollover, and due to the belt rollover time is a standard time. It is operated with the machine with the pendant. So operating 6 meter line extra length, it is getting a time consuming. So we did a model wise data analysis. So we optimize the length, and the 6 meter length of the belt is reduced. Due to that, that time was reduced. Accordingly, on U-bolt tightening, if you see U-bolt tightening station, there is a multi-spindle. The multi-spindle RPM is a standard RPM, and which is slow in nature. So pre-tightening is time is getting increased, and we have total 6 axles. 6 axles into each U-bolt is having four nuts. So many joints are there, and 2 multi-spindles are there. So the time is getting exponentially increased. So we have analyzed that. So can we use a pre-tightening pneumatic tool? Yes, we can, and we did, and successfully it is tried out and implemented. And reutilization of line. Somewhere initially sub-assembly of gear bolt and washer is at leaf spring station. With the rebalancing, we've seen that we have reduced the leaf spring station work content and rebalance with the operation shifting to the gear pump assembly. And the other important recommendation is that we have 3 to 4 axles, front axle, rear axle, and each axle is having a different tackle manipulator. So while dropping an axle, front axle, that person is taking one manipulator, and for rear axle, he is taking another manipulator. So the time in changeover of manipulator is there. So we have commonized the single manipulator. So it has reduced a time on axle dropping station drastically. So these are the recommendations we have implemented, and it has resulted into cycle time reduction of this particular 3 stations, and which is lying in between 7.5 to 8 minutes on all these 3 stations. And this has successfully implemented our 64 JPD setup on chassis A line. And the conclusion and benefits are: manpower we have reduced by 20 numbers. Line efficiency is improved from 87 to 91%. Output per person, if you see, it is improved from 1.18 to 1.28%, 1.28 per person per truck. And the cost benefit, overall cost benefit, this cost benefit calculation is based on the electricity used in the second shift, manpower cost, and other conversion like canteen cost, transportation cost, everything. For a year, this 1.96 lakhs means 1.9 crore cost benefit we have received, and the cost benefit is supported by the finance team also. Finance team has audited and approved this cost benefit. This is all. Future scope, yes, looking at the project and the lesson learned from the project, we can improve with the same methodology, with the same CFT culture. We can improve our quality rating from 89 to 95%. We can eliminate the NVS, taking these project lessons into the consideration of other lines as well. These are the future scope. As I mentioned in the literature slide, the references, whatever we have used, are mentioned over here. That's it from my side. Any questions?
Good, good, Mosin.
Yeah.
Two things I have liked most, which I have not seen in the earlier students. The one is the legend. You have used the legend in various slides. That is the good
Mhm.
thing which we liked. And also you have mentioned the date and slide number, because if we have any doubt, so we are able to mark the slide number. So those 2 points are appreciable. I have four
Okay.
questions for you. So first one is
Okay.
the what is the learning from the literature? Give one example of learning from the literature which you have referred. Almost 11 to 12 case studies you have referred. So what was the learning from the literature?
Okay, now learning from the literature is that one of the literature I really like that the case known as case study, which was presented in the JIPM. That case study was regarding the identification of the problems. Uh, just a minute, phone. Identification of issues, then identification of NVS and the bottlenecking. So one is the post issue happening analysis, and one is the potential analysis. So with that case study, the debottlenecking and all the methods, that case study I liked much. So
Okay.
this
So
is
the
one.
approach used for bottlenecking by the case study, which was presented
Yeah,
by case
yeah,
only, that was helpful for you. So basically, how to
yeah, yeah,
identify the bottleneck and the approach used to eliminate the bottlenecks. Good. The
yeah, yeah,
second
yeah.
question for you is the challenges which you faced while doing the kaizens or improvement on your in your area.
Hmm. Basically, challenges. What we faced is that basically truck operations in automotive industry compared with the two-wheeler industry and the passenger vehicle industry is different altogether, because the size of the parts are key in the nature. So one factor, ergonomic factor plays an important role in truck manufacturing industry. So while implementing the kaizens, whatever we have implemented, we face the many challenges to handle the bulky parts, ergonomically bending motions and all everything. But we overcome the challenges using one methodology called SSES. It is a simplified safety ergonomical assessment from Mahindra Advanced Production System. So we used and utilized that system to analyze ergonomical issues properly, and we while implementing the kaizens, the observed challenges were overcome with that system.
Okay, good.
The,
So you are
whatever I
saying that
mentioned,
fatigue was the main area which
yeah,
to
yeah,
reduce the fatigue was the
yeah,
main challenge for you. Involvement, change of
yeah,
mind of people was the second thing. Okay,
yeah,
this was the main thing for you to implement. Now the third question is, you did your triple I. Okay,
yeah,
so
yeah.
so from what are were the learnings from triple I, which you have, which has supported you in your project work?
Basically, if you see my project is totally based on the industrial engineering only. The root of my project is only industrial engineering, because it is productivity improvement. It lies in our line balancing, then work content, then ergonomics, everything, data analysis. So industrial engineering helped a lot. How? I'll tell. Number one, while doing this project, I have to work on ergonomics. So ergonomics is a basic part of industrial engineering. So the literature, whatever I studied in industrial engineering regarding ergonomics, it is a help a lot. Another one is that work content, takt time, line balancing, these are the basic elements of industrial engineering which I have studied, that helped me to analyze and implement my project properly. Another one is that basically industrial engineering is what? Industrial engineering is to analyze the bottlenecks, how to increase the profit of the organization. So if you see my basic hurdle was I am not able to support my organization to increase the profit, because I'm somewhere there is a profit drop due to NVAs and all. So data analysis helped me a lot. So industrial, the basic purpose, what I was learned in industrial engineering, that helped me a lot. So data analysis, ergonomic study, work balancing, stacked content, everything. So overall, in last 2.5 years and 3 years, I learned in industrial engineering that really helped me a lot.
Okay, good. The last one, you did your triple I in 3 years, right? So, what was the toughest thing which you have found in triple I while doing the while pursuing the triple I? Which thing was tough for you? which subject was there or anything else? Hello?
Hello.
Hello. So,
Huh.
are
Am I
you
audible?
audible? My question was, in your while when you are doing your triple I, so which subject or the topic was the toughest for you in triple I?
Uh, Basically, if you see in triple I, there was probability or finance. These are the or some are the mathematical calculus subjects. But if you see finance is a little bit different from our day-to-day engineering area. So finance, I feel a bit difficult. I took an coaching from an experts and I cracked it. But as far as difficult level is concerned, finance seems to be some challenges for us.
Okay, thank you, Mosim, and all the best. We'll let you know the result. Okay,
Yeah, yeah.
chalo,
Thank
chalo.
you. Okay. पवन
Yes.
हा झालं का रे म्हणजे
हो हो
हे
झालं
झालं
झालं झालं
कसं
झालं
वाटलं काय
चांगलं वाटलं काही अडचण नाही